some of these transformational aspects, we are starting to see them in agriculture as well. And what is driving that is the issue of food security. This is an item that is starting to appear more and more in the agendas of many governments. We have an increasing trend in terms of number of population, unfortunately really bad habits in terms of our attitude toward food and food wasting. Land is competing with agriculture. We have different activities competing, and on top of that we have the potential consequences of global warming, all of which could actually adversely affect our capacity to produce food. Australia in particular, I think we need to make a big effort in order to be able to remain sustainable and profitable, and by that also ensure that we have a participation in terms of the food production globally. Australia's agriculture produces, the revenues from agriculture are about 3% of GDP, and that's only for what we do in the farming. So if we include together the value added to agriculture from the farm gate to the actual plate, so we get to 12% of GDP. 60% of our agricultural produce is exported, and as a country we have a very, very high value of labor. So in terms to ensure the long trend of productivity, what we need to do is rethink about how we're doing some of the things. And the key aspect of here, which is where robotics come in, is productivity. How can we do more with less? So if we look, for example, in some of the ways we're currently managing the crops in a farm, there is a lot of activities around sensing, gathering information, getting lots of data, and then that information is processed by humans, which are farmers or agricultural consultants. And then basically what we do is we act on the crop by applying inputs. And what we're trying to do is to maximize the yield and the quality of the produce, and at the same time, because our system interacts with the environment in terms of weather, but also adverse movement of markets, we're trying to make the system robust to those variations, and therefore reduce volatility in yield and also in quality of the produce. So this is some of the practices what we do today. So what we envisage in the future is something like this. So the sensing, we will continue integrating some of the techniques we have now, but now we have added unmanned aircraft and also ground robots and sensor networks. And that has the opportunity to collect vast amounts of information, which will be very hard for farmers to process. And this is where we come into what we call the second machine age. During the first machine age, through the Industrial Revolution, we augmented our mechanical power. Now we're using machines to augment our capacity to process information and to think. So all these amounts of data will be processed, and the farmer will give in the right amount of information that is needed for decision making. And also robots will be used for acting on the crops, and therefore they will be used not only for sensing but also for acting. And some industries are trying to move towards, well, can we have plant-specific management or even animal-specific management in the areas of livestock. Now, if we look at our agricultural ecosystems, we have a few components there. One is the farming enterprise, which is the picture I have just portrayed. But if we look at the value-added chain, which is what happens once the produce leaves the farm, there is a similar situation in which robotics, automation, and autonomous systems, data processing can be used. And also we need to develop, once we combine these things, what we call the agri-environmental intelligence, which is how do we develop the infrastructure in order to be able to implement a good way of doing management of our agricultural industry. And this moves across all the different commodities, which goes from livestock to grains, cotton, sugar, and the like. Now, one question that is particularly important today and for this audience is how the Center of Excellence fits in this. Well, as it was mentioned, there are four main themes in which the center seeks to develop fundamental theory, which is robust vision, vision and action, semantic vision, and algorithms. And all these activities cut right across of what we need in agriculture, specifically for two problems: robot enabling sensing and robot enabling acting. So if we look at robust vision, well, the robots will be operating on a farm with changes in conditions in the environment, lighting. Vision and action, the robots will be conducting operations of harvesting some of the crops, especially in horticulture. So we need to be able to detect where the crops are, and we can use motion to know where the crops are, but then and vision to move the robot, but you can also move in order to improve your vision. Semantic vision, once the robot detects there is an object, what type of object it is, and how do we interact with that object. And something that was mentioned as well, algorithms and architecture. Those robots will try to operate with efficient use of energy. So in order to do that, we need to do a lot of processing on board of the robot in order to avoid transmitting large amounts of data for processing of the robot. So it's important to do that. Now, so in summary, I think robotics and autonomous systems have the potential to bring a transformation in agriculture, and the work that we are doing at the center is key as an enabling factor in order to allow robots to be able to do this. Thank you very much.